Hi everybody. In this video I'm going to talk to you about how to identify parts of a parabola. Parabola is this red graph that you're looking at, and it is created from that function you see over in the top left, and that's called a quadratic function. So with that in mind, let's go ahead and begin. Every parabola has either a highest point or a lowest point, also known as a maximum or a minimum. This particular parabola has an absolute minimum, and it's called a vertex. The vertex is always indicated by an ordered pair, so this particular one is at -1, -4. That x value right there is going to be something that we will see again in a little bit. Every parabola also gets cut in half. Now the place where this parabola gets cut in half happens to be right here. So I'm going to draw this line, and you might have noticed that this green line passed right through that vertex, and this has its own name, and it's called the axis of symmetry. Symmetry has to do with two sides of a whole part being virtually identical to each other when they are cut in half. So this axis of symmetry, being a line, has an equation. And the equation is always going to be x is equal to some kind of number. Now, the reason I said that the x component of our vertex is important is because that number happens to be the same number that we use to complete our equation for the axis of symmetry. So the equation is x is equal to -1. And a simple reason is because any point along this imaginary line, any point has an x coordinate of -1, and that's why the equation is x equals -1. Okay, other parts of the parabola include a y-intercept, and that would be right over here. The y-intercept is a point that sits on both the graph and the y-axis at the very same time. So this is our y-intercept, and it's located at 0, -3, or you can simply write -3. Although I recommend writing it as an ordered pair, because saying -3 could also mean this point right there, and that is definitely not a y-intercept. Okay, so we have vertex, y-intercept, and our axis of symmetry. What else do we have? Well, it turns out that we have these 2 points over there, and they are called x-intercepts because of where they are sitting. So an x-intercept point is a point that sits on both the graph and the x-axis at the same time. Now, with parabolas, there are 3 possibilities, and I'm going to illustrate them real quick over here for you. So as you can see, we have 2 here. We have one there, one here, and we have one right there. But there are 2 other cases as well. So the other case would be if we have a parabola that hits the x-axis only one time. And if it hits it only one time, then we have only a single x-intercept. So one x-intercept. The other case, the final case, is where we have case B. We have a parabola that is either floating right above the x-axis or it is hanging below the x-axis. And in that case, there are no x-intercepts because neither the highest point, which is there, nor the lowest point, which is there, ever touches the x-axis. So there are no x-intercepts in this case. So we have either one x-intercept, we have 2 x-intercepts, as you can see on the red graph on the right side, or we have no x-intercepts at all. So fortunately, we have a case where we have 2 x-intercepts. And like with the y-intercept, I'm going to write down their ordered pair. So this one is at -3, 0, and this one is at 1, 0. Okay, because they involve zeros for your output or your y's, x-intercepts are often called the zeros of a function. Okay, so this covers the basic parts of a parabola, from vertex to y-intercept to the axis of symmetry, and finally to the x-intercepts, and 3 cases that you could encounter when working with these types of functions. So I hope this video helped you better understand. Please stop by, leave a comment, and as always, thanks for taking time to watch. Bye-bye.